Hello everyone, welcome back to another video. In today's video we are going to be learning about imaginary numbers, and yeah, let's get started. So when we have a number whose square is -1, we refer to that as I. And I is again a number whose square is defined as a number whose square is -1. So I is a number whose square is -1. So we know what I is. Now, I squared is -1. This is something you always need to remember. Many people define I as just square root of -1. So you can define it either way. Either way, I want to move on. And there's a couple of powers you need to memorize when it comes to I. I recommend you memorize these. First off, I squared, we know it's -1. I cubed is I squared times I, which is I squared is -1, -1 times I, -I. So -1 multiplied by I is -I. I to the fourth power, you need to memorize. I to the fourth power is -I times I. Since I cubed is -1, multiply that by I, you get -I squared, which is just 1. I to the fifth, this one's optional if you want to memorize it, but I'm sure to write it down, is 1 times I. I to the fourth is 1 times I. I to the sixth you need to memorize. It's just I squared, because we take I, I squared. So when we have I to the sixth, we have I multiplied by I, which is I squared, which is just -1. And then I to the seventh is again optional, but I just recommend you just memorize these. And this is because we have certain problems when we use these imaginary numbers where we're asked to raise to the power of big numbers such as 2,000, I to the power 2,000. Some people also use. So you're gonna have problems like this. So the way we're gonna solve these is when we have these powers of I, we notice there's like a pattern. We have -1, -I, 1, I, -1, and we should check I to the seventh should be equal to I cubed if this pattern is going right. We're going to check that. I to the sixth, -1 times I, -I, and sure enough, it matches up with I cubed. So I to the seventh is I cubed, and we see from this pattern that every time we go, we're going -1, -I, 1, I, -1, -I. And this pattern is useful because we're cycling in powers of 4, or groups of 4. So if I have I to the 8th, that's -I times I. negative I times I squared, negative I squared is 1. And again, we have 1. So negative I 1. And that matches the pattern when we have I cubed and I to the 4th. So when we see this pattern, we need to notice that whenever we have I raised to the multiple of 4, it's going to be 1. So I'm going to give an example. When we have I raised to any multiple of 4, let's say 20, it's always going to be 1. So basically I raised to, say, I raised to z, or a multiple of 4, is always 1. So, we can have I to 2400 still going to be 1. So that's very useful, especially when we're faced with problems in which it asks us to raise I to the huge powers and stuff. So we're going to try this out with I raised to 101. 101, we know that 100 is a multiple of 4, so we can write this as I to the 100 plus, not plus, multiply. We're going to multiply it by I to the 100, multiple of 4. 100 is a multiple of 4. I to the 100, it powers just 1 multiplied by I. So I to the 100th 1 power is just I. So we can see we can do cool things with I. We can raise it to huge powers and be easily able to figure it out. Let's try a different problem. Let's say we have I to the negative 101. Now we know that this can easily be written as 1 over 101. This can easily be written like this. And we know I to the 101 power is just I, but if we didn't, what we do is, well, first I to the 101. Again, a quicker way of doing this, we realize I to the 100 is a multiple of 4. That's just 1. 1 times I is I. So we have 1 over I. Now we have 1 over I. So if we have I as the denominator, that's not going to be too good. So as we learned, we did the rationalizing denominators. We might be able to do the same thing here. Multiply top and bottom by I. It's just I. This is I squared. So then, yeah, we have I divided by I squared. This is just I over I times I. These cancel, and we have I. So it's still going to be I if we have negative 1. And yeah, so we can raise these to powers, which is pretty easy. We can raise I to powers. We can also solve equations with them. So let's say I have x squared equals negative, we're starting with negative 9. Negative 9. Well, we know that 3 squared equals positive 9, right? So, and we know I is just square root of negative 1. So we might be able to use it over here. we can do 3i, and if we square 3i, we're going to get 9. We get a 9. I'll get I squared. I squared is -1, -9. So we know that this will satisfy the equation. And we can also have a -9i squared. Oh, I'm sorry, -3i squared. So when we write this here as plus minus 3i as our two solutions, because this is just the same as minus 3i and plus 3. The same thing as writing it like that. I like to write it like this because it's more efficient. So we're going to try a different problem, similar one. And let's say that we have x squared equals -20. Immediately we notice if this was positive, this is x squared. It was if this was positive, and we're at a big if, because x squared is 20, x would just be root 20, and we would just get 20. Square root of 20. Same. We have a similar thing over here. First thing we want to do, square root of 20. We can simplify this. We can square root of 20 can be written as 10 times 2, 4 times 5. So, and then we have 4 perfect square, 2 root 5. But this isn't the answer. This is not the answer. Remember, we have -20. Remember, we have I. We have I. So we can just write this as 2 root 5 multiplied by I. But I don't like to write it like this. We can also write it like 2i root 5. And then remember, two solutions, plus minus. So remember, minus 2i. And that is our solution to x squared equals -20. Let's try one last example. Let's say we have 2x squared equals, we're going to do -40. -40. Alright. So over here we have, 2x squared equals -40. What I'm first going to do is I'm going to get rid of this 2 right here. That's just x squared -40 divided by 2. X squared is just -20. And we know how to solve this from last time. So we know that we can just square root of 20 2 root 5. And then we have an I because -20. So our answer is once again 2. We have the plus minus, and that is our solution to this. And you have the same rules, just get rid of the x, and yeah. So essentially it's the same problem as we did last time. These two are equal. Alright. So hopefully this video helped. And that's just basic, or just the basics of imaginary numbers. The next videos will cover more in depth of imaginary numbers, and I hope everyone found this video helpful, and hopefully you guys found this video helpful. And yeah.